Okay, here's where we left off. I showed you guys how to do what the protocol is for graphing a piecewise function in Desmos. So one thing you can do also, if you wanted to, you could break this into pieces, separate pieces on separate lines, and even like make them different colors. So I've got all three pieces graphed in this function because you can see they're separated by those two commas. It's kind of hard to see that. It's pretty small. I can make it a little bigger. But if I wanted to, like, I could just take that last piece off and just come down and make a new function. I have to call it something else. I could call it like g of x, like something like that. Maybe make it a different color. And then you could do that for each piece if you wanted to, and then individual pieces would show up as different colors, so you could distinguish them. Okay, the other thing you can do here that's kind of nice, I think where we left off yesterday, we were talking about the weakness of graphing a piecewise function on technology. And what was that? What's the big weakness of this compared to what we did when we graphed this stuff in class yesterday? Okay, the endpoints, right? Yeah, we can't tell which endpoints are open and which are closed. So just based on this graph, you can't tell if an ant walked up to the value x equals -2, where would he stand, if anywhere, right? Maybe they're both open. We can't tell. So one way you can fix that, and I'm going to go back and write this as this is one area where writing it as a single function is kind of nice. So I'm going to go back and undo what I just did a little bit ago. So it's all written as a single function, f of x. And then we could go down and build some ordered pairs. Our transitions, our boundaries between the regions are at -2 and 4, correct? Based on the graph, those are the places where we have breaks in the function, where we're transitioning from one piece to another piece. So I want to know what's happening at those points. So I could build the ordered pair. -2, that's my x coordinate. And for my y coordinate, I don't have to calculate it. I've already got a function that will calculate the y coordinate if I input an x coordinate. So I could just do f of -2. And look what it does. Okay, so it tells me where is the closed endpoint then? Right there. Okay, where's the open endpoint? It would be the other one. It's not going to graph an open endpoint for me, but it will graph the closed endpoint. And then I know to go in and just treat that as an open endpoint because it doesn't have a point there. Okay, does that make sense? And I can do that for both at the same time. I could then just put a comma between the ordered pairs. So after that first ordered pair, I could make a second ordered pair at 4, f of 4. And there's the other closed endpoint. And if I want to label them and get the coordinates, there they are. Okay, make sense? All right. So there's how you can graph piecewise functions on Desmos. And I've got a little graph there just to remind you kind of what we did. And I just drew in open endpoints to remind you that even though they don't show up there, those are the open endpoints. Now I want to show you how to do this. Maybe I'll have you guys practice one of these in a second, but let's show how we can do this on the TI-84 also. TI-84 plus. Raise your hand if you have one of these. TI-84 plus. Okay. Number of them. I'm gonna take a little time because even if you don't have it now, you might be getting one. Remember, these are allowed on the SATs and on AP tests and things like that too. So they're probably worth having. Okay, to graph, I'm just gonna graph the same function. I guess we'll just graph this one. How about? I don't know if that's the same one, isn't it? Yeah. Okay, so we just go into y equals. Let me see if I can make this. Oh, that's not what I want. Okay, there. Is that the one I want? No. That one? No. I guess just that one. Okay. Can't make it any bigger. So on the first one, if I want to make a piecewise function, it's really easy to do on the 84 plus. You go to the math menu. Actually, hang on. No, you don't. You go to the calc menu. You go second, calc. Anytime you want to graph some kind of a, like do calculus, which you'll talk about in a couple of years, or if you want to graph some weird kind of functions, you go calc. Nope, never mind. That's not it. I'm done this in a while. Okay, strike that. That's not it. Go back to y equals, and you do go math menu. Yeah, you do. Okay. And then I want to go down this list a bunch. There it is, piecewise. The easiest way to actually do this is not to go down. It's to go, if I go back to this, if you want to go clear to the bottom of this thing, just go up and it cycles around, it loops around. So I can go up to the bottom of the list and get to piecewise really quickly. So I choose piecewise. How many pieces do I want? I get to choose by using the arrows. I can increase and decrease the number of pieces. That looks good. So I'll go down and hit OK. There's my 3 pieces. Top piece is supposed to be 2x. So there's 2, my x variable. Scoot over to the right, and I want to do x is less than or equal to -2. Okay, so x is, well, where's less than or equal to? That doesn't show up on the keyboard. That's in what's called the test menu. All the inequalities are in the test menu. So are the logical words like and or, stuff like that. All that shows up in the test menu. So I go second, test, it's behind the math button. And I want less than or equal to, which is number 6. So I can just type a 6. Less than or equal to -2. Okay, I'll scoot down. Next, I've got -1 minus x. And then the domain of that piece is x is greater than -2 and less than 4. So I'm going to make it look just like that. -2. Got to go to the test menu. I want 5. Go back to the test menu, grab another one of those. Okay, so that looks good. And then finally, the last piece is defined as -3 when x is greater than or equal to 4. So go back to that test menu, choose option 4, put in a 4. And then now if I just hit graph, I'm at the mercy of whatever I had the window set up how I had it set up last time, which may not be correct. So rather than hitting graph, remember what I told you guys, you always just go zoom standard. Just hit the zoom menu and go 6. Zoom standard will reset the window to kind of its default size where it goes from -10 to 10 on the X and the Y axes. There it is. Okay. And again, if I want to know, it's not quite, I can't put I don't think you conveniently, well, you can, but I don't know if it's worth it. Probably not worth it. You can do a stat plot. I don't think it's worth it. Let me mess with that a little bit, and I'll see if I can find a way to do this that's really easy and convenient. But if you want to know where the closed endpoints are for a graph, the easiest way then would be to just go to those places on the graph and see where the ant stands. So I can do this by hitting trace and then typing in the x value. So in this case, I want to enter the x value -2 and hit enter. And look what it does. It puts me right there at the point with coordinates -2, -4. So I know that's the closed endpoint. Okay. Then I can go trace 4, x equals 4. It'll write x equals 4 and hit enter. And it puts me right there. So I know that that's the other closed endpoint. So the open endpoints must be the endpoints of this horizontal or this slanted segment in the middle. Okay. That was really quick because I know not everybody has one of these, but I want to just give you a little heads up on how to do that. Any questions? Okay. Why don't you guys really quick do that one? Just do that one on Desmos, and I want to just see that you can do it. So go to open up Desmos graphing and crank that one out.